Hi again, this is Miss Park. So here's part 2 of the trigonometry unit that we're doing with angles around the unit circle. Okay, so we are now on the 3rd page of the little booklet that's 5 pages. And so this part 2, I'm going to go through all the examples of working with these angles to complete this little booklet of 5 pages. Where we left off in part 1 is we looked at drawing angles in the 4 quadrants, and we looked at determining their sine, cos, and tan in each of these 4 quadrants. Okay, and always we draw the right angle triangle that's sitting on the x-axis, and sometimes that triangle is flipped into quadrant 2, 3, or 4, but that's okay because we just label the sides, and once we label the sides with the correct measurements, including the sine, then we can figure out the sine, cos, and tan. And then at the end of the last video, I showed you this little memory aid, which is cast, tells you in which quadrants each of the trig ratios is positive. Okay, so let's work on some of these things. And I did promise you we were going to do trig without a calculator, so here we go. So what is the cosine of 120 degrees? So cosine of 120, so first thing we're going to do is we're going to draw it. Now I see there's a blank that says, is the trig ratio positive or negative? I'm just going to leave that for now because I'm going to start every solution with the diagram and then we can answer the other questions. Okay, so 120 degrees, the first thing we do is we're going to draw it. So 0, 90, 120 is going to be somewhere in quadrant 2. This is 120 degrees. Okay. Now here's the part that the part 1 didn't really get to, which is if I want to draw this triangle over here, okay, what are going to be the measurements of the side lengths? Okay, so right now we don't really know, but we do know something. We know that if this is 120 degrees, then the related angle, remember related angle, it's the one between the angle and, between the terminal arm of the angle and the x-axis in the same quadrant. That was from part 1. So the related angle in here is 60 degrees. This angle here is 60 degrees. Now, I still don't have any side lengths, but I know something because 60 degrees came from a special triangle. And in the special triangle with the 60 degrees, the side across from it was root 3, right? That's the opposite. The adjacent side is a 1, and the hypotenuse is 2. So what I've done is I've drawn my special triangle with the 60 degrees in quadrant 2. And there's one thing I have to add on to this, which is because I'm in quadrant 2 and the x's are negative here, then this 1 is actually negative 1. So my cosine of 120 is really, because the same triangle is flipped over from where it would have been in quadrant 1 to quadrant 2, it's the triangle with the 60. So it's going to be the cosine of 60 degrees in this triangle, which is adjacent over hypotenuse. So adjacent over hypotenuse, that's cosine. And that's going to be negative 1 over 2. So the exact value of the trig ratio cosine 120 degrees is negative 1 over 2. And notice cosine of 60 degrees would have been in this quadrant, same triangle, just flipped. Cosine of 60 degrees would have been 1 over 2. But 120 is in the other triangle, in the other quadrant, so it's negative 1 over 2. Is the trig ratio positive or negative? It is negative. And if you like, now you can check with cast. Cast says that when your angle is in quadrant 2, only sine is positive. So it makes sense that cosine is negative. All right, let's try next one. Sine of 150 and draw. Every solution starts with the diagram. 150 degrees, it's also quadrant 2. 150 degrees. Now, my related angle is 30 degrees. So let me write that again. Related angle is 30 degrees. It's the angle between the terminal arm and the x-axis, 30 degrees. Now I label this triangle because it's a special triangle. So across from 30 degrees is 1. Beside 30 degrees is root 3. And the hypotenuse is 2. because I'm in quadrant 2, my x coordinates my x values are negative, so I'm going to add a negative there. Sine is opposite over hypotenuse. So opposite is 1 and hypotenuse is 2. So what is the exact value? It's 1 over 2. This one's saying, is sine 150 positive or negative? I can tell you it's positive because it's 1 over 2. Let's check with Cass, see if I'm right. Yep, quadrant 2, sine's going to be positive. Let's keep going. Tan 330. Look at us. We're doing trigonometry with no calculator. Tan 330. Okay, where's 330? 0, 90, 180, 270. Here's 330. All right. We're always, always, always going to draw the related angle inside here. Okay, so the related angle is 30 degrees. Always, always include the related angle in your diagram. All right, now from 30 degrees, use the special triangle. So opposite is a 1, adjacent is a 3, and hypotenuse is a 2. If you ever get confused about which one's a 1 and which one's a root 3, remember that when the angle is really big, your opposite side is going to be big. And when your angle is small, your opposite side is going to be small, right? Because the triangle opens bigger and smaller, right, to the opposite side. Which number is bigger, root 3 or 1? So root 3 is bigger because that's about 1.7, and this is 1. So across from 60 degrees is always the bigger one. Across from 30 degrees is always the smaller one. And the hypotenuse will always be 2. You can calculate that using Pythagorean theorem. Okay, so what is the exact value of the trig ratio? So that's going to be opposite over adjacent. We're going to use a 30 degrees. Oh, I got to make my 1 negative because I'm down below the x-axis where the y's are negative. And my root 3 is positive, so that's fine. So opposite is negative 1 and adjacent is root 3. And please leave your answer not rationalized. If you did use a calculator and you put in tan 330, you might get an answer that is a rationalized radical. You also might get a decimal, but don't give me any of those. I want to see this because this comes directly from the special triangle. Okay, sine 225. 225 is in quadrant 3. Here's 225. And draw the triangle. The related angle is 45 degrees. So I've got to 180 plus a little bit more to 225. So the related angle is 45 degrees. This is the other special triangle with the 1, 1, and root 2. Now, the x's are negative in quadrant 3, and the y's are also negative in quadrant 3. So the sine of 225 is going to be opposite over hypotenuse, which is going to be negative 1 over root 2. All right, oh, let's fill these in. Is tan 330 going to be positive or negative? Well, I can see it's negative here. And sine is going to be negative here. And you can go and check that, double check that with cast. All right, did a whole bunch of trig with no calculator, which is pretty cool. All right, so here we go. Sine theta is 1/2. So determine the angle. Now we have to determine the angle. We still don't have a calculator, right? So sine theta is 1/2. I'm going to try and draw this. Where would sine theta be positive? So try to remember, what is sine? Sine is opposite over hypotenuse, and the opposite is the standing up side. It's the up and down side. So where would that be positive? So that would be positive in quadrant 1 and in quadrant 2. Okay, so what I really have is, if you were to punch this in the calculator, theta equals inverse sine of 1/2, you would get one answer. It would tell you 30 degrees. But because we know that sine can be 1/2 in more than one place, we're actually going to get two answers. So if we were in quadrant 1 and I drew this diagram, then sine is opposite over hypotenuse. That's one of the special triangles. That's the 30-60 special triangle. So what goes here, 30 degrees or 60 degrees? Right? 30 30 goes here? Because 30 is across from the 1, which is the smaller side, and 60 is across from root 3, which is a longer side. So in quadrant 1, it's 30 degrees. In quadrant 2, if I was to create the same triangle, then the related angle in here would be 30 degrees. But angles are measured in standard position. So in quadrant 2, the measure of the angle is not 30 degrees. So let me write this down. So in Q1, the angle is 30 degrees, but in Q2, the related angle is 30 degrees. And theta, which is the angle we're solving for, is measured in standard position. So it would be 180 minus 30 degrees. So two answers. I'm just going to write here two answers just so you can see that our calculator would have only given one answer. But if you know your triangles and you understand this going around the circle, then you should be finding two answers. All right, let's do the next one. Cosine theta is negative root 3 over 2. So I'm going to draw, okay? Where is cosine going to be negative? So remember, cosine has to do with the adjacent side, which is the side-to-side side. And so where is that negative? Well, that's going to be over here in quadrant 2 and quadrant 3. Let me write over here, sine positive in quadrant 1 and quadrant 2, cosine negative in these two. So I'm going to draw a triangle over here, and my cosine is negative root 3 over 2. So now cosine is adjacent over hypotenuse. Hypotenuse is always positive. So I know it's my adjacent that's going to be negative. And this one's going to be a 1. Right? What angle goes here? Again, that's the related angle. So I got my Q2 answer and my Q3 answer. Okay, what angle goes here is 30 degrees. So in quadrant 2, my related angle, sorry, before I write, let me do this. My related angle is 30 degrees. Okay, so my answer in quadrant 2 is not 30 degrees, it's theta. Theta is in standard position. Right, this is theta. Theta is measured in standard position. So that would be 150 degrees. My second answer is I'm going to draw the triangle in quadrant 3. And so in quadrant 3, there's my negative root 3 and there's my 2. The related angle is still 30 degrees, but to measure theta in quadrant 3, I've got to go all the way to 180 plus another 30. So it's 210 degrees. It's two answers again, 150 and 210. Do the last one. Tan theta is negative 1. So where is tan negative? So remember that tan is opposite over adjacent. That's going to be where the opposite and the adjacent have different signs. Either one's positive and the other, right? One's positive and the other's negative, basically. Right? So if they were the same, both positive or both negative, your tan ratio would be a positive number. So where does that happen? That happens in quadrant 2 and quadrant 4. So I'm going to draw the triangle in quadrant 2 and quadrant 4. Now I can see in quadrant 2, so this is negative 1 over 1, or it's 1 over negative 1. So this one, the adjacent is 1 and the opposite is negative 1. This one, the opposite is 1 and the adjacent is negative 1. Well, we recognize this triangle. That's the other special triangle. So what angle goes here? Right? 45 degrees. Both of them 45 degrees. So tan is negative in quadrant 2 and quadrant 4. The related angle is 45 degrees. So my quadrant 2 answer is going to be from 0, but not all the way to 180. It's 45 degrees less. So let me just do it this way. 180 minus 45 degrees. So that's 135. And in quadrant 4, I'm going to go all the way around to 360 except for 45 degrees. I'm going to go all the way up to there. So this is theta. This is also theta. Okay. So in quadrant 4, I have 180 degrees. Sorry, I have 360 degrees minus 45 degrees, which is 315 degrees. Okay, again, 2 answers, and your calculator would have only given you 1. All right, let's do this last one here. For angle theta, sine theta is negative 3/5 and cos theta is positive 4/5. Determine angle theta. So little bit of a lie, we do need a calculator for this one. Okay, but how do we do, if I want to figure out what theta is given this information, I should have 2 answers because sine is going to be negative in 2 places. And this one is going to give me 2 answers because cosine's positive in 2 places. So where does my angle have to be where sine is negative and cosine is positive? All right. For sine to be negative, I need all the y values, like everything, all the opposite sides, which are the up and down sides, to be negative. So that's going to be here. And cosine positive, I'm going to need everything that's all the adjacent, so the side to side, to be positive. So I'm going to here. So where are they both? Quadrant 4. So I'm going to draw now quadrant 4. I'm going to draw my triangle. Cosine is 4/5, so this is going to be adjacent is 4 and hypotenuse is 5. Sine is negative 3/5, so here I have it, negative 3/5. Now I'm going to need the calculator because this is not a special triangle. So I do need to figure out what the related angle is. So for the related angle, use a positive ratio. Don't use the negative ratio because remember the negative ratio just tells us where the triangle is. Use this positive ratio. So it's going to be cos inverse of 4/5. And that's going to be about 37 degrees. But it's in Q4, so theta is not 37 degrees. So if I'll put my 37 in here. That's not theta. Theta is measured in standard position. So I've got to figure out what the whole angle is. So theta is going to be 360 minus 37 degrees, which is 323 degrees. Okay, so occasionally the calculator comes out when something is not a special triangle. All right, hope we're doing okay with this stuff. The more examples we do, the better it gets. So please practice. Question 1 here is saying the point A34 lies on the terminal arm of an angle in standard position. Determine exact values for sine, cos, and tan. You know this. Okay, draw the triangle and figure out sine, cos, and tan. The second one's doing us the same thing, except that the triangle is in quadrant 2. You're still going to draw the triangle, and you can figure out sine, cos, and tan. What do you notice about these two? So this is actually the examples that we did a couple pages ago, so you can answer that question. These ones, determine which quadrant the terminal arm lies. So it's not asking you to solve for theta. Please don't solve for theta here. Just without a triangle, which quadrant is it? You can tell by whether the trig ratio is positive or negative. So you should have 2 answers for each one of these. Question 5. Given cos theta is 3/7, determine the exact values of sine theta and tan theta. Okay, then calculate theta. Now, all of this we can do without the calculator, just with drawing. Calculate theta, we'll need the calculator because this is not a special ratio. It's not one of the special triangles. Okay, so this is like CP 131 example 3, right? In that example, you were given one of the trig ratios and you were asked to find the others. Let's see if I can find it. Here. This one over here. You were given one of them and you were asked to find the other ones. okay, which we can do just from drawing the triangle. The way this question is different is because cos theta is going to give us two possibilities. There's two quadrants in which cos theta is positive. So when you're drawing the triangle, you're actually going to have two different triangles, one in quadrant 1 and one in quadrant 4. That's where cosine's positive. And so you're going to have two different answers. You're going to have a pair of sine and tan in quadrant 1 and a different pair in quadrant 4. So you'll have an answer for quadrant 1, another answer for quadrant 4. And same thing with this one. Sine theta is 3/4, so it means sine's positive, so there's going to be one in this in quadrant 1 and one in quadrant 2. Okay, and so you'll have two sets of answers for cos theta. So in quadrant 1 you'll have a cos theta, and then in quadrant 2 you'll have a different cos theta. Right? And remember, the numbers are going to be the same. It's just whether they're positive or negative because of where the triangle is. Okay, so now we have everything you need. So please do your practice, and thank you for watching.